Did you know that a cup can hold a secret that's been hiding in plain sight for centuries? A cup is more than just a simple container for holding liquids. It's a reflection of human ingenuity and the ability to shape materials into functional forms. The first cups were made from clay and date back to around 10,000 BCE. These early cups were often used for ceremonial purposes and were highly prized for their beauty and craftsmanship. As civilizations evolved, so did the materials used to make cups. From ancient Egypt to modern times, cups have been made from a wide range of materials, including glass, metal, and ceramic. But have you ever stopped to think about the mathematical patterns that underlie the design of a cup? For centuries, mathematicians and scientists have been fascinated by the geometry of everyday objects like cups. From the spiral patterns on a cup's handle to the curved lines of its body, math is woven into every aspect of its design. One of the most striking mathematical patterns in a cup is the Fibonacci sequence.
This sequence, in which each number is the sum of the two preceding numbers, appears in the arrangement of seeds in a sunflower and in the branching of trees.
In a cup, the Fibonacci sequence can be seen in the way that the handle curves around the body.
The spiral pattern on a cup's handle is a classic example of a Fibonacci spiral.
This spiral is a mathematical concept in which the distance between each turn is a fixed proportion of the previous turn. The Fibonacci spiral is a fundamental pattern in mathematics and appears in countless natural and man-made objects. But what makes the Fibonacci spiral so special? It's a self-similar pattern, meaning that it repeats itself at different scales. This self-similarity is a hallmark of fractals, which are mathematical sets that exhibit the same patterns at different levels of magnification. Fractals are found everywhere in nature, from the branching of trees to the flow of rivers. And in the case of a cup, the Fibonacci spiral is a beautiful example of a fractal in action. But that's not the strangest part. Did you know that the mathematical patterns found in a cup can also be seen in the way that it's used? For example, when you pour a liquid into a cup, it follows a specific mathematical path. The path that the liquid takes is determined by the shape of the cup and the force of gravity. As the liquid flows into the cup, it follows a curve that's determined by the cup's geometry. This curve is a classic example of a mathematical concept called a catenary. A catenary is a curve that's formed by a chain or rope hanging under its own weight. And in the case of a cup, the catenary curve is formed by the liquid as it flows into the cup. But what does this have to do with math? The catenary curve is a mathematical concept that's used to model a wide range of physical phenomena. From the shape of a bridge to the flow of a river, the catenary curve is a fundamental pattern in mathematics. And in the case of a cup, the catenary curve is a beautiful example of math in action. So the next time you pick up a cup, remember that there's more to it than meets the eye. A cup is a reflection of human ingenuity and the ability to shape materials into functional forms. But it's also a showcase for mathematical patterns and concepts. From the Fibonacci sequence to the catenary curve, math is woven into every aspect of a cup's design. And as you continue to explore the world of mathematics, remember that it's all around us, even in the most mundane objects like a cup. But that's not the end of the story. Did you know that the mathematical patterns found in a cup can also be used to solve real-world problems? For example, remember that it's not just a simple container for holding liquids. And the catenary curve has been used to design bridges and other structures that are both aesthetically pleasing and functional. So the next time you see a cup, remember that it's not just a simple container for holding liquids. It's a reflection of human ingenuity and the ability to shape materials into functional forms. And it's also a showcase for mathematical patterns and concepts that can be used to solve real-world problems. If you found this fascinating, subscribe for more incredible stories like this. Want to learn more about math and its applications? Check out our playlist on the mathematics of everyday objects. And if you have any questions or topics you'd like to discuss, leave them in the comments below. Thanks for watching, and we'll see you in the next video.